In problem 1 of exam 3, we have the three isotopes of carbon. Carbon 12, 13, and 14. Carbon 12, of course, is the one that's most in abundance. Carbon 14 is the one that decays. And so, one of the ways we date things is by the relative abundance of carbons 12, 13, and 14. We often use mass spectroscopy to do this, and this problem was set up to ask you to calculate how far would these three carbon ions be separated in a mass spectrometer. So let's start with this is basically the same problem three different times, right? So we know that the force on them due to a magnetic field is the charge times the velocity vector crossed with the magnetic field, right? And so since in this problem they are perpendicular, the velocity and magnetic field are perpendicular, this is just QVB, right? So the force on each particle is QVB. This leads to a centripetal. This is a centripetal square acceleration. The force, centripetal force, which is v squared over the radius. Right? So if we were to set this up, the only thing that comes out different for each one of them, that's one step further. So now the centripetal acceleration, or centripetal force, equals QVB, right? That yields mv over r equals QB. The quantity that we're interested in here is the radius, and solving for the radius of curvature, the radius of the circle, right? These charges are going to be going in a circle due to the magnetic field. The radius of the circle that they go in is just given by mv over qb. All right. Now, let's put in some numbers. R12, all right, is the radius for carbon 12, and the mass of carbon 12 is 1.99265 times 10 to the minus 26, right? And that's kilograms. And the velocity, these are all going at 10 to the 6th meters per second, right? That's the velocity, and we're going to divide by the charge. Now the charge is 3 times 1.6 times 10 to the minus 19 coulombs, right? Because we have a charge, these are triply charged, plus, plus, plus. That means we have a positive 1 unit of charge. 1 unit of charge is 1.6 times 10 to the minus 19th coulombs multiplied by 3. And the magnetic field is 1 Tesla. Alright? So this is exactly the same equation for every single isotope. So I'm going to pop over and I'm going to calculate this, or set up this calculation in Excel. So the mass 1.99265 E minus 26. The 1E6 is the velocity, 3 times 1.6 E minus 19 is the charge, and 1 Tesla is the magnetic field. So the radius curvature, or the radius for carbon 12 is its mass times its velocity divided by the charge divided by the magnetic field. Let me move that over into view. Okay. And now I'm going to come in here. Let's take a look. For carbon 13, right? This is 2.1587 times 10 to the minus 26th, right? And everything else is the same. I know, you're crying foul. You didn't get to use Excel on the test. And carbon 14, 2.32475, 2.32475, 10 to the minus 26 kilograms, and okay. So we have our answer here actually for all of them, right? For this is 4.15 times 10 to the minus 2 equals 4.15 times 10 to the minus 2 meters, which is 10 to the minus 2 is centimeters, so 4.15 centimeters. All right. R 13, well, I'm going to just copy all of this and then change the mass, right? Because the mass changes to 2.15870, 2.15870, and the answer, popping back over to Excel, 4.5 centimeters. centimeters. Okay, and then for the final one, right? For the final one, we want, oh, I'm sorry, that's R13. All right, copy all of this. R14. All right, the mass is 2.32475. 2.32475, and the resulting radius is 4.84. 4.84 centimeters. So the question is, what is their spacing in millimeters as they pass through 180 degrees? So after 180 degrees, the carbon 12 will be 8.3 centimeters away from where they enter the field. Carbon 13 will be 9 centimeters, and carbon 14 will be, what's this, 9.68, right? So the distance for carbon 12 that it goes diameter, right, is 8.3 centimeters. Diameter for carbon 13 is 9 centimeters. And the diameter for carbon 14 is 9.68 centimeters. So if I'm going to say how far apart are they in millimeters, they are spaced the C12, let me just do this. So from 13 to 14 and to 12 is 9 minus 8.3. All right, so that's going to give us 0.7 centimeters or 7 millimeters, right? And the distance from 14 to 13 is 9.68 minus 9 is going to be 6.8 millimeters. And there you have it, their spacing after going through 180 degrees. And that's problem 1.